So this is a project that me, Fabio Shiro, and Sandhill, which is Bruno, not Bruno Maya, the other Bruno, worked on this week. What it is, it's an infrastructure project, okay, another one, to allow Cartesi applications to consume any data that was posted to Celestia. And why that? The idea is that Cartesi has, as we all know, provides high computational power since an app-specific rollup that you can have entire VM for yourself to do stuff with Linux. But often the amount of data that you could put in an application limits a lot of what you can do, right? So you can process a lot of data, like databases, do lots of statistics, but you don't have enough data to do much, right? And on the other hand, Celestia is a mature project that provides a modular DA network, allows blobs up to 2 megabytes, which is much more than normally we could get on the base layer, and is already even deployed to mainnet, so it's something that's out there. So putting these together seems to be a really interesting thing. What's the global idea here? So the global idea is to relay data from Celestia to the application without changing much how Cartesi framework works, right? So somebody sends blob data to Celestia. That could be the dApp front end itself, or somebody else will send like, let's say some census or whatever, some database beforehand. And the Celestia network, there is an addition to it, which is called blob stream, which submits commitments of that to a contract on Ethereum network. So it's actually a number of Ethereum networks have this support. And so once the commitment is there, your dApp could send an inclusion proof of that blob. So that sends a specification what the blob is to the Celestia relay contract. It will check with the blob stream contract if it's valid, so if it's included in the commitments that were submitted there. And if so, we can safely relay it to the input box. And then the node will fetch that input as any other input, send it to the backend. The backend will see that it came from the Celestia relay contract, so he knows that is a valid thing. And he can request the data itself from using generic IO. So it's a GIO thing here. You send a definition, the ID of the blob, and you will go to Celestia and fetch the data itself and put it inside. So the idea is that with this, you could potentially have something that's verifiable, because this procedure of getting the data is something that could be proven on chain afterwards by checking the inclusion proof and using something like what Alex just showed, which is a ZK proof of the data. What's the Merkle of the data? All right, so where's the stuff that we did? We have a number of repos. The main repo actually has pointers to the other ones. So we have a rollup Celestia repo where we have a Celestia relay contract, which is deployed on Sepolia, base Sepolia, and Arbitrum Sepolia. All of these are networks where the blob-stream contract is deployed and receive commitments, real commitments from the real Celestia network. In this case, we are talking about the Mocha testnet from Celestia. They also have for Ethereum mainnet, Base mainnet, and Arbitrum mainnet. We have a version of Nonodo called Brunodo, which is a development version of Nonodo. There's a special branch there where we added Celestia support. This includes Celestia GIO service, which is the one that fetches data from Celestia. And also, this version of Nonodo provides a CLI that adds commands to submit data to Celestia, which is kind of not very user-friendly, but it does it for you. You can then check the proof to see if the commitments are already submitted to the base layer, and relay that data to the dApp. And then we have a test app just to see what happened. Let me try to show something here. I think the video is too long, but I'll skip it along. So you have to actually do things. you have to have a light node, a Celestia light node, which we have one calendar put something up here.
Quack.
Okay. So anyway, I'll fast forward here. You send something there to Celestia. You get where the blob is included, the data that you want included, and then you can, after a while, you can check that it's there. The video showed things going on, but okay. And finally, you can use that other use the other thing to relay the data. In the end, you will get something like this in the back end. So you have a handle advance. It will check that it came from the right place. It will build the GIO ID, send it over there, and get the data. And the data was something like Cartesi rocks here, which was the data that we submitted before. So that's it.